In our third set of examples today, we're going to look at multiplying complex numbers, and this is where we're really going to use that fact that I squared is equal to negative 1. Whenever we end up with an I squared, we're going to substitute negative 1 in for that. So, in the first case, what we're going to do is just distribute that 3i. Again, you treat the I just like you would any variable except if we end up with I squared. And that's when we're going to substitute negative 1 in for that. So distributing the 3i times negative 5 is negative 15i. And a lot of times, treating the I just like another variable, they do not have to be like terms in order to multiply them. So then, when we distribute the 3i to the 2i, we end up with plus 6i squared. And in this case, that 6i squared becomes 6 times negative 1, because I squared is equal to negative 1. So we have negative 15i minus 6. And to write that in the true complex form, the a plus bi form, we are just going to change this position, but be careful when doing that and make sure the signs stay with the numbers. So for example, if we put the 6 first, we keep this negative with the 6, and we keep this negative with the 15i. So in this product, the real part is negative 6, the imaginary part is negative 15. I'll actually jump down to n before we start talking about the foiling that we have to do in L, M, O, and P. So, when multiplying these two, 7i times 3i is 21i squared. And once again, I squared is equal to negative 1. So the product is negative 21. Now, that's still a complex number. In a plus bi form, that would be negative 21 plus 0i. And the real part is negative 21. The imaginary part is 0. So the real numbers are actually a subset of the complex numbers. So now with the foiling of these, when we're multiplying two true complex numbers, and we're going to do it L the same way we did 4 plus 3x equal or times negative 1 minus 2x. We're going to treat the I as a normal variable. The only difference is if we end up with an I squared, that's going to be equal to negative 1. So when we FOIL, we take 4 times negative 1, which is negative 4. 4 times negative 2i, which is negative 8i. 3i times negative 1, which is negative 3i. And 3i times negative 2i, which is negative 6i squared. Now, combining these two like terms, negative 8i minus 3i, we end up with negative 11i. And we end up with minus 6 times negative 1. I squared again is equal to negative 1. So when we perform that multiplication, negative 6 times negative 1, that becomes 4 minus 11i plus 6. And what that results in is another set of like terms we can combine. The negative 4 plus 6, which is 2 minus 11i. Again, our result is a complex number with a real part of 2 and an imaginary part of negative 11. Now with M, again we FOIL. Negative 6 times negative 6 is 36. the like terms, 6i minus 6i, they cancel. And I squared once again is equal to -1, so minus -1 becomes plus 1. And combining those like terms, we end up with 37. Now again, that is a complex number where the imaginary part is just 0. Okay? So the result is 37. Moving on to O and FOILing. 2 times 4 is 8. 2 times 5i is 10i. -3 times 4 is -12i. -3i times 5i is -15i squared. So combining the like terms, we end up with 8 minus 2i, 10i minus 12i, and then minus 15 times the -1 becomes plus 15. Again, I squared is always equal to -1, and then that gives us 2 more like terms to combine, so we end up with 23 minus 2i. Real part is 23, the imaginary part is -2. And finally, P, -4 times -4 is 16, plus 20i minus 20i minus 25i squared. So combining the like terms, the 20i's cancel out, so they're gone. -25 times -1 is positive 25. And we end up with a real number of 41. So that is multiplying complex numbers. The big thing to remember is that whenever you end up with an I squared, that's always equal to -1.